Hi all, welcome back. And in this progressive video series for EKS Anywhere on bare metal, in this video, we are going to be talking about and showcasing how to facilitate different machine configurations along with node groups, specifically for bare metal EKS Anywhere clusters. I'm joined by my colleague Raj. Hi, Raj.
Hello, everyone.
Hi. So, since this is a bare metal environment, there is every possibility that you could have different types of machines actually. Maybe, the use cases could be GPU versus non-GPU or servers with different configurations or whatever may be the reason. And you want to actually build these, node groups or the pools of these machines separately and then target your applications separately on each of these node pools or node groups, so to say. We will see how this can be practically achieved in the context of EKS Anywhere with bare metal. What we will do is we'll start describing the cluster configuration file and the hardware.csv, which lies at the heart and core of how these advanced configurations can be established. And I'll walk you through some of these concepts in a very practical manner, then follow it up with a live cluster deployment and do the right observations. So with that, Raj, if I can request you to share your screen, and we can actually look at the hardware.csv to start with. So in the hardware.csv, if you recall our previous videos, we had each of the line entries for every node actually, specifically highlighted. And towards the end of the line, you can see the type equal to CP. And in the previous, videos, you would see for the worker nodes, the type was equal to worker, right? And these are all manually typed values. You can write whatever you want, ABC, XYZ, whatever, against the type. As long as this information can be referenced or cross-referenced in the cluster configuration. And we will see how now we can actually use the type field to actually cross-reference different types of nodes actually. So what you are seeing is, like if you recall, in the previous videos, we have specifically 3 node cluster, 1 control plane and 2 worker nodes. That's the constraint of our lab. And what we will do is basically the control plane remains as is, but the 2 worker nodes, we will assume just for assumption that these are 2 different node types, okay? Let's say server types. And you can see that the type for the second line, which is the first worker node, type equals worker-md-0. And for the second, we are mentioning type equals worker-md-1. Like I said, you can put it as ABC, XYZ, whatever it is. Here, just for a proper nomenclature, we are keeping it as worker-md-0, worker-md-1. With that said, this becomes the inventory file, and we will see how this particular, obviously, that, by virtue of the MAC addresses, the machines get identified and the entire Pixie boot and the DHCP process starts and all that, typical saga will start from cluster provisioning standpoint. But now let's visit our cluster configuration file. And we will establish, let's open it in the notepad, Raj. So first, what we will do is we will scroll down to see how the machine configurations look like for each of the worker nodes. Now, if you see, in contrast to the previous videos, where we had a very simple cluster deployed, here I have 3 machine configurations. 1 for the control plane, 1 for the first worker node, which is line 72 to 84, and then a separate machine configuration for the second worker node, which is line 87 to 99. In the previous deployments, these two machine configurations were not separated out. There was a single machine configuration for both the worker nodes because both were identical, assumed to be identical, again in the same pool and all that, right? Here we want to split out these two nodes into two different pools. Like I said, here we just have one each worker node for each pool. You could have, 10, 20, whatever be that number in, respective node groups actually. Now, let's start firstly establishing that cross-referencing value with machine configuration for POC 5-WK-MD0, which is line 75. That's the name of the machine configuration for the first worker node. And if you look at the spec hardware selector type, line 78, we've specifically mentioned worker-MD-0. So this value and what you see in the hardware.csv, that need to match. And that match basically tells Tinkerbell, that this machine belongs to this particular hardware type. And then this particular machine configuration will be applied to that, to those set of machines, whichever bear that hardware type equals to, in this case, worker-MD-0. So that's the first, iteration of the machine configuration. The second one, if you scroll down, likewise, we have another machine configuration which says POC 5WK-MD1, right? That's the second machine configuration targeted for our second worker node. And the hardware selector, what we have said is worker-MD-1. That's the cross-referencing that is happening here. And that establishes the linkage between your inventory file and the machine configuration in the cluster configuration. Now, if you just want to basically, associate different machine configurations, that's one thing. But we want to also overlay the concept of a node group actually, such that when these machine configurations are applied to a set of nodes or hardware, we can label them separately. Now that node labeling basically will help you establish the node group concept, right? Now, if you scroll up, Raj, what we are doing is starting with line 28, you can see worker node group configurations. We have now two instances of worker node groups because we want to establish these two node groups actually, right? And the first one basically line number 33, punches it with the machine config we just saw down there. And you can see that we are applying a node label group:MD-0 to this particular node group configuration. So whichever nodes bearing the machine config POC 5-WK-MD0 will bear the node label of group:MD-0. And the second one basically is, the node group configuration, which bears the Tinkerbell machine configuration of POC 5-WK-MD1 will come up with the labels of group:MD1. So those node labels will essentially ensure that you can classify your those particular nodes differently. In this case, the worker node 1 and the worker node 2, they will come up with these particular respective labels. Also, just as I don't have a GPU and non-GPU and a different server configuration here. So just to kind of establish how differently we can do things, here the use case that we are assuming or expressing is that the first worker node will run the Kubernetes version of 1.28. Okay. In this case, only one node. If you had 10 nodes there, those will come up with that Kubernetes version. And the second node group, which is bearing the machine config of POC 5-WK-MD1, will come up with the Kubernetes version of 1.29. So it may be a use case where you could, be expressing, your pod deployments on different Kubernetes version. for different nodes. Again, there are many use cases and applications of why node groups exist and how they can be kind of materialized into your environment. Now, with that said, everything else stays same. Unless you have not followed the previous videos, I would really encourage you to see those of what is a typical life cycle of a cluster creation and other things that we've actually described, including upgrades and what, right? Here, we will simply, in the interest of actually focusing on the core topic, which is node groups and, differentiated hardware configurations, we will start the cluster creation process. And then we will resume the video once the cluster is fully created and then do the observations and some quick deployments, right? So let's start our cluster creation itself. Okay. So we're going to roll out this command, EKS create cluster, typical providing the hardware CSV. And once the cluster is fully created, we will start resuming our, observations and whatnot, right? So see you soon. Okay, so the cluster is finally ready. Am I correct, Raj?
Yes, it is.
Okay, so let's execute some of the commands, starting with seeing our node structure. Maybe we can clear the screen. I think we can get a better. Okay. So when we look at kubectl get nodes, couple of things that we should highlight here is, okay, so this is a Ubuntu based cluster, number one. Second is you look at the Kubernetes versions itself, you can see that all the three nodes, the control plane, the worker node 1 and the worker node 2, they are on different Kubernetes versions, which is a good thing that allows us to run mixed versions of Kubernetes. Obviously, there are some constraints in terms of how many versions can be spaced out, but we have the ability to run different versions on different node groups and also differing from the control plane. That's one. The second one that we will see now is the output of the command. Let's spec out that command, the second one. Okay. So if we see the node group labels on the MD0 and MD1, we can see that, we are getting the nodes and we just kind of, on the metadata, we are actually deriving the labels. We can see that worker node 1 is labeled with MD0 and the next one is labeled with MD1. And that we can actually, of course, use to actually target our applications while being deployed to specific nodes, right? Now we can actually shall we deploy the applications, or Raj, you want to capture some other output? Okay, so
we can go ahead and deploy.
Yeah, let's just see this particular YAML first. If you can cat this particular YAML. So we have two YAMLs, right? Busybox md0.yaml. So this one, if you look at the node selector, it says node selector is group md0, which is the label applied on your worker node 1. And then we have another YAML. Let's cat that as well. So the next YAML, the node selector is group colon MD1, right? So we'll deploy both of these busybox pods, and let's see if they come up on, the respective nodes as such. We'll go ahead and apply the busybox. So the first one is deployed. Let's also deploy the second one. Okay, cool. So let's see pods -O wide. We can remove the -A. Let's just focus on the default namespace. Okay, so we can see that we have both the pods running, the BusyBox first one, which is intended to go on worker node 1, and BusyBox the second one, which is intended to go on the second worker node. So let's look at the node information for MD0 BusyBox and then correlate it with the hardware. So we can see that indeed it has gone on to the first worker node, right? And likewise for the BusyBox, second BusyBox, if we correlate the node information, we can easily see that it's gone on the second worker node, right? So that's just a quick, way of establishing, uh, how we can, in summary, how we can deploy these node groups or pools of server configurations in an EKS Anywhere bare metal cluster, and then use whatever techniques, mechanics you have to actually stream your applications or deploy them in those notebook aware topologies. So hopefully this gave you a peep into this important topic. It's a short and sweet video, but nevertheless very important. So I hope you stand to gain from this. Thanks a lot, Raj. Thank you.
Thank you, everyone. Bye-bye.